Okay, so let's discuss the derivation of the theoretical air-fuel ratio formula. So to find this equation, we have to understand how much air we need if we have an ultimate analysis of the fuel. So we can imagine, imagine an analysis per element. No? So we can start with carbon. No? So for carbon, you can imagine if you have, let's say, a carbon molecule, you can oxidize the carbon with oxygen, and this will form carbon dioxide, right? So this is also balanced already. So if you imagine how much mass per molecule is this to the balancing. So you have, let's say for example, this one is, so carbon is equal to 12, right? So you have 12 kilograms of carbon plus you have oxygen. Also oxygen's molecular weight is 16. So 16 times 2 is 32. So you have 32 kilograms of oxygen to form how much, no? So we can find the molecular weight by adding this. So you have 12 plus 32. So you have 44 kilogram of carbon dioxide. So to think of this, if you want to combust 12 kilograms of carbon, you need 32 kilograms of oxygen. Okay? So basically, if you divide this by 12, divide this by 12, you can find here that this is just 1 kilogram of carbon plus, so this will be 8 over 3 kilogram of oxygen. And then you have 11 over 3 kilogram of carbon dioxide. Okay? So basically, you can imagine to burn kilogram of carbon, you need 8 third of a kilogram of oxygen. So basically, if you want to burn 1 kilogram of carbon, no, you need 8 third of a kilogram of oxygen. Okay, and we can rewrite this in terms of the air. No? So we know that 1 kilogram of air, just A na lang, no? Has 23.1% of oxygen. No? So 0.231 kilogram of oxygen. Diba? If you can remember the math basis of air. So if you rewrite this, you will get what? No? So you will get here 11.5 kilograms, no? Of what? Of air per kilogram of carbon. No? You can cancel this out. No? Okay, we're good with carbon. So how about hydrogen? So let's say you have a fuel, let's say H2. So this is diatomic. To combust hydrogen, you need one half of a molecule of oxygen to produce water vapor, no? Or one molecule of water vapor or water. So this is already balanced, no? That's why we have one half here, so that it will be balanced. Now, if you find the molecular weight of this, you have 2 kilograms of hydrogen. So 32 times 2, no? So O2 is 16 plus times 2. Sorry, 16 times 2 is 32. But divide by 2 since this is one half. So we have 16 kilograms only of oxygen. 16 kilograms of oxygen. To create what, no? So this will be 2 plus 16. So we have 18 kilograms of hydrogen. Or sorry, or of water. H2O. Okay? If you simplify this, divide this by 2, no? You will get 1 kilogram of hydrogen, so sorry, plus 8 kilograms of oxygen, and then 9 kilograms of H2O. So we only divided everything by 2, no? So basically, what we can imagine is to burn 1 kilogram of hydrogen, you need 8 kilograms of oxygen, diba? And we can write this in terms of air, no? So we can just have a way to convert this kilogram of oxygen into kilograms of air. So we have 1 kilogram of air all over 0.231 kilogram of oxygen. Okay, that okay? And then if you multiply this, you will get a value of 34.5 kilogram of hydrogen. Sorry, of air pala, no? Of air. over kilogram of hydrogen. Okay, we're good with this too. No? It's fairly easy. How about for sulfur? No? So if you have sulfur on our fuel, so if we want to combust sulfur, we want to oxidize with oxygen to create sulfur dioxide. No? So this is already balanced as well. So sulfur's molecular weight is 32, right? So we have 32 kilograms of sulfur plus you have 2 times 16, no? For oxygen. So we have 32 kilogram of oxygen to produce. So how many is this? So we have 32 plus 32, right? So this is 64 kilogram of sulfur dioxide, no? So SO2. So if we divide this by 32 again, no? Divide this by again so that it is in lowest term. So you have 1 kilogram of sulfur plus 1 kilogram of oxygen to produce 2 kilogram till 2 kilograms of sulfur dioxide. So basically, you need 1 kilogram of oxygen to burn 1 kilogram of sulfur. So you have here 1 kilogram of oxygen per 1 kilogram of sulfur. No? So we can convert this again in terms of air. No? So we have 1 kilogram of air per 0.231 kilogram of oxygen. Yeah. So we can equate this into 4.32. So the unit is kilogram of air over kilogram of sulfur. Now the last one here, so it should be red now. So the last one is oxygen. This is a little bit tricky, no? But the simplest explanation for me is that when you have oxygen in your fuel, diba? So I've mentioned this before that if you have oxygen in your fuel, it is usually paired with hydrogen, meaning it is water, no? So counterintuitive, counterintuitively, more oxygen in your coal actually is detrimental, no, to your fuel. So if you have oxygen, then you have water, basically, in your fuel, which is wet. No? Okay, diba? So you can imagine you need or you will need somewhat way you need less oxygen, no, for the kilogram air for sorry, why did I say that? Oh, no, 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 no. But if you have oxygen, I mean, sorry, baliktad pala yung sinabi ko, no? Pero most of the time kasi oxygen is combined with hydrogen. But, um, sorry, yung term pala na dapat ginamit ko is free hydrogen also. If you have free hydrogen, ibig sabihin hindi siya paired with oxygen. Pero kung hindi siya paired with oxygen, usually meron siyang ratio ng hydrogen and oxygen. And yung ratio ng hydrogen and oxygen can be seen here, no? So if you say you have 1 kilogram of hydrogen is 8 kilogram is to 8 kilogram of oxygen, no? Diba? Based on this. So parang if you have 1 kilogram of H2, then you have a same proportion of oxygen that is 8 kilograms some way. Kaya pag multiply mo daw to ng inyong, let's say, ratio ng oxygen per fuel, so parang kilogram of oxygen per kilogram of fuel, okay, yung ating oxygen content, then this will be, no, makakancel lang yung oxygen natin dito. No? So you can get here, parang O2, no? So number of oxygen content in our fuel over 8. And then you have here kilogram H2 per kilogram of fuel. Now this will be important, no? Kasi ibig sabihin, ima-minus natin to dun sa ating hydrogen kanina dito. No? Or not really this one, but with a present hydrogen. So that the equation will be 11.5C. No? So this one plus 34.5 hydrogen, no? Which is this one. Pero again, minus pa kasi ng O2 over 8, no? Which is this one plus 4.32 S, which is this one. Okay? So, you can do a unit analysis kung i-check nyo. No? So, yung 11.5 kasi is kilogram air per kilogram carbon. Yung C naman, no, is kung based sa ultimate analysis, ilan yung percentage ng carbon, di ba? So, ibig sabihin, ilang percentage ng carbon is, yung numerator mo is yung carbon content over the total, no? So, kung ilan yung mismong total or yung kilogram na fuel. So, makikita nyo, magka-cancel lang siya, magiging kilogram air per kilogram fuel. Same goes for this one, no? So, yung H2 mo, as you can see here, sige, itong 34.5 na lang muna, no? So, you have kilogram air over kilogram H2. Okay, and then this one is kilogram H2 over kilogram of fuel. Same goes for this one. No? So, kilogram H2. Actually, ilagay ko na lang sa same ano, no? So that we can cancel this. No? Cancel, cancel. Same goes for this. No? So, kilogram air per kilogram sulfur. Yes pala, no? And then kilogram sulfur over kilogram ng fuel. So, this will also cancel out. Kaya mangyayari, magiging unit mo is in kilogram. In other words, this will be in kilogram air over kilogram fuel, which is also the theoretical amount. No? Makikita natin ito sa equation na to. Okay, so that's all. Thank you guys for listening.